Hello everybody! In this video we're going to identify even and odd functions from their equations. This again is from enVision's Algebra 2, Topic 3, Lesson 7. So we're going to determine if this is an even, odd, or a neither function. Let me grab it. We'll have remnants as a last example in my notepad. So let's get past that. And here we go. So the first thing I would actually do here is just start testing. I would say is f of -1 equals f of 1. And I'm going to start with the even definition because my degree here is even. So I'm going to look at the even definition. Oh, there we go. Which is f of -x equals f of x. All right, so I'm going to see if 4 to the -1/4 plus 5 equals 4 times 1 to the 4th plus 5. Well, when I do a negative times a negative times a negative, that will give me a positive. So that'll be 4 times 1 plus 5 equals 4 times 1 plus 5. Because 1 to the 4th is 1. So we get 9 equals 9. So it appears that this is an even function. I could test a second part, or what I can do is I could look at f of -x. Does this really equal f of x? And using that negative in my problem. So f, or 4 -x to the 4th plus 5. Does this truly equal 4x to the 4th plus 5? Well, like I said before, if I multiply a negative, so this is what we're looking at. So we're looking at a -x, 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 -x plus 5. If I do a negative times a negative times a negative times a negative, we'll get 4x to the 4th because we'd get a positive. And on this side, we do have a 4x to the 4th. So we do. Our left side does equal our right side. We don't even have to substitute numbers in. Substituting numbers in does helps you see it. But if you want to take it to that extra step and keep with the variables to see if they are the same, you can. All right, so we do have them the same. This is an even function. Okay. So the next, let's see there. Why use a variable rather than specific value? You must show that f of x does equal f of -x, or that -f of x equals that. So might as well just use the x's to show that, and not just one value. Like I said, you might want to use one value, but using multiple values or even all the values makes your argument a lot stronger. So if anything you get from math, even if you don't get the algebra, is learning how to make your argument, make your reasoning stronger. Okay, is the function odd, even, or neither? Let's grab this guy and move him over to notebook. Sorry, I know but I'm going to do it again. Okay, so is the function odd, even, or neither? Again, I'm going to try by leaving the negatives in there. So I'm going to do g of -x. Does this equal g of x? And again, the whole reason why I went with the odd one, f of -x, negative here, equals -f of x. The whole reason I went odd is because this degree, the highest degree, is odd. And that's my only reasoning why I went odd. All right, so let me plug in the -x. So 2 times -x cubed plus 3 times -x. Does this equal -2 times x cubed plus 3x? Okay, again, thinking about this, how this breaks apart, this is -x times -x times -x, which again is going to be -x cubed, which is really like saying 2 times negative 1 times x cubed. So that's going to be negative 2x cubed. Negative times a positive would be negative 3x. Does this really equal negative 2x cubed plus 3x? I could do this two ways. I could pull out the greatest common factor of a negative here. I could distribute this negative. Since we're more familiar with distribution, I'm just going to distribute that negative. And it is. We do have the same function on the left and the right. So this is an odd function. And again, you could take multiple points and test them out. But again, it might be better just to replace with a negative x. All right, you have two try-its. Try them. Show if it's either odd or neither. And I will catch you in the next video.